Hello everyone, welcome back to Earth Science online class. I hope you are doing well. Today we will start our lesson from chapter 5, section 7 and 8. The topics are groundwater, hot spring, geysers, and geothermal energy. Okay, about groundwater. Surface water that does not run off into streams and rivers may seep down through the soils into the upper layer of the Earth's crust. There, water fills space or pore between rock particles. Water may also fill fractures or cavities in rock that were caused by erosion. Water that fills and moves through this space in rock and sediment is called groundwater. Groundwater is an important source of fresh water that we use in Cambodia. Look at this figure. You can see there are two zones. This yellow zones is called zones of aeration, and below it is called zones of saturation. Between these zones, there is a boundary that we call water table, and in this zone of saturation there is rock called aquifer. Below the zones of saturation it is impermeable rock. So impermeable rock does not allow the flow of groundwater, while aquifer is a kind of rock that is permeable that allow the flow of groundwater. Okay, let me explain you about zones of saturation, aeration. The zone that lie between the water table and Earth's surface is called zones of aeration. And the zones of aeration is composed of three regions. The uppermost regions of the zone here. This is whole soil moisture. It's the water that forms a film around grain of topsoil. The bottom region is just about the water table, this part. So is capillary springs. Water is drawn up from the zones of saturation into the capillary springs by capillary actions. Capillary action is caused by attractions of water molecules to other materials such as soils. For example, when a paper towel soaks up a spill, capillary action draws moisture into towel. Between the soil's moisture regions and the capillary springs is a region that is dry, except during period of rain, and does contain air in its pore. Then, zones of saturations, the layer of an aquifer in which the pore space is completely filled with water is the zones of saturation. The term saturated means filled to capacity. The zone of saturation is the lower of the two zones of groundwater. The upper surface of the zones of saturation is called water table, as I already told you. And next slide about the movement of groundwater. Like water on the surface, groundwater flows downward in the response to gravity. Water passes quickly through highly permeable rock. Permeable rock means aquifer, and slowly through rock that is less permeable. The rate at which groundwater flows horizontally depends on both the permeability of aquifer and the gradient of the water table. Like this, it is a kind of gentle steep slope, so water move gently. So the gradient is the steepness of a slope, and velocity of the groundwater increase as the water table gradient increases. Topography and water table also affect the flow of groundwater. The depth of the water table below the ground surface depends on the surface topography, the permeability of the aquifer, and the amount of rainfall, and the rate at which humans use the water. Generally, shallow water table match the contour of the surface. During the period of prolonged rainfall, the water table rises. During the period of drought, the water table falls and flattens because water that leaves the aquifer is not replaced. The moving of groundwater erode the land to create a landform, like you can see here. A curved form when acidic water seeps into the cracks, and eventually widen the cracks into the limestone, dissolve the rock, and enlarge the crack to form something like this in the ground. We call cave, and the roof of cavern collapse to make sinkhole. Sometimes to make sinkhole that can be dangerous. And water that seep from the roof of the ceiling create a kind of dripping stone called stalactite, and when the calcium carbonate drip to the surface to form another conic shapes called stalagmite. So if you go into a cave, you will see these kinds of stone and water moving in the cave like this. About hot spring and geyser. And on the left side, this is hot spring. On the right side, it is geyser. So let me explain you about hot spring. Groundwater that is heated when it passes through rock that has been heated by magma. Hot groundwater that is at least 37 degrees Celsius and that rises to the surface before cooling produces a hot spring. When water in a hot spring cools, the water deposits mineral around the spring edges. So the deposit forms step-like terrace of calcite called travertine. Mud pot formed when chemically weathered rock mixed with hot water to form a sticky liquid clay that bubbles at the surface. Mud pots are called pen pots when the clay is brightly colored by mineral or organic material. And geyser, a hot spring that periodically erupts from the surface pools or through small vents are called geyser. A geyser consists of a narrow vent, here it is narrow vent, that connect one or more underground chamber. These are called chamber. With the surface, the hot rock that make up the chamber walls superheat the groundwater. The water in the vents exerts pressures on the water in the chamber, which keep the water in the chamber from boiling for times. When the water in the vents finally begin to boil, the boiling water produces steam that pushes the water above it to the surface. Release of water near the top of the vent relieve the pressures on the superheat water further down. With a sudden release of pressure, the superheat water changes into steam and deploys toward the surface. The eruptions continues until most of the water and the steam are empty from the vent and chamber. After eruptions, groundwater begins to collect again and process is repeated, often at regular intervals. anywhere on Earth where there is magma or hot water, we can generate geothermal energy. So hot groundwater can be dry turbine to generate electricity, as you can see like this figure. So hot water rises into this block and becomes steam, and this steam turn generator, mean turn turbine of generator to generate electricity. So electricity is sent it to household, and the water becomes cool water, and this cool water eject back through a valve back into the ground. So this move to the magma and become steam again, and the process repeat to generate electricity. And these questions will be shown on another section. So after watching this video, please go to sections of assessment. Please answer the question. Okay, thank you for watching.